Assalamu alaikum and welcome all. In video number 359 we shall estimate vector autoregression, and finally we will use some diagnostic tests. Let me first show you the data table, and there are four variables: IP, ISM, payroll, and T-bill 3 months, and this is monthly data from 1960 month 1 up to 2014 month 12. So let me start my data file. This is my data file here, and these are the various variables. Monthly data, total number of observations is 660. First of all, object and proc. Sorry, this is a new object, and var, and let me also change this, call it US var. Okay, and here I will specify this is a standard var, and these are the four variables. And since this is monthly data, so I am using from 1 to 12th leg, and we will specify this model, and C will be used as exogenous variable, that is constant. So clicking OK, I have this estimation output of the var. There are four equations, and since we have used 12 legs for each variable, there are four variables, so there are 49 coefficients for each equations, and the total number of coefficients is 196. So 49 multiplied by 4 is equal to 196. So this is the output of the model, and after this I'll check the leg length criteria, and for that I'm going to this, and see, this is monthly data, so I'm using 12 legs. So this is the var leg order selection criteria. These are the endogenous variables. This is exogenous variable, that is constant. Total number of included observation is 579. Two criteria, that is Akaike information criteria and Hanan-Quinn criteria, recommends that we would pick 10 legs. Akaike information, the VARs information criterion suggests 9 legs. Since two criteria, that is AIC and HQ criteria, suggest to use 10 legs. So let me estimate var, and my endogenous variables are IP, ISM, payroll, and T-bill 3 months, and since this is the two criteria suggested us 10 legs, so I am using Eviews to use 1 to 10 legs. So this is my new model, and here there are four equations. This is the equation for IP, and it has been regressed on four variables with 10 legs of each variable. So there are 48 coefficients for the four variables plus the constant. So for each equation there are 49 coefficients, and for the overall var there are 164 coefficients. Sorry, for each variable there are 10 times 4, that is 40 plus 1, 41 coefficients, and for all the four equations there will be 41 times 4, 164 coefficients. These are the R squared values, and these R squared values are high because there are 41 coefficients in each equation, so it gives us better fit. These are the adjusted R square values. These are the other statistics used for standard OLS model, and these are the statistics associated with standard VAR model. After that I may see the residual of the these variables. So this is residual for the IP, these are the standard residual for the ISM, T-bill, and these are the residuals for the payroll. We can also check the correlation matrix. This is the correlation matrix for the 4 variables. There is no high correlation for the up diagonal variables, but these are one for the diagonal. We can also check the covariance matrix. This is the covariance matrix. Since half the diagonal elements are not equal to 0, so it means that the errors are correlated with each other. There are some contemporaneous correlation. After this, we may also check the stability of the model. So this table shows that all these values lie inside the unit circle, so VAR satisfies the stability condition, and we can also confirm this by using the AR roots graph, and it shows that all the variables, that all the coefficients lie within the unit circle, so there is no problem of instability. So this model is stable. And after that, we can also check the correlogram of these residuals, and we can check the graph of the correlogram, and this is the various autocorrelations with the approximate 2 standard errors, lower and upper bounds. Let me maximize this. These are the various values of the autocorrelations with approximate 2 standard error bounds, and we can also check the residual. These are the various correlograms. We can check the autocorrelation LM test with this. Similarly, we can check the normality test. This is the normality test, and similarly we can also check the white heteroscedasticity with cross or no cross terms. So these are the various sorry, this is estimation. Let me check the residual with the no cross terms, and these are the various probabilities. Some are significant and some are not significant. So this is the estimation of the VAR model in Eviews. I have used US data for 660 observations. These are months from 1960 January up to December 2014. I estimated the VAR model, then I used various criterion to select the appropriate leg length, and following a Kaike information criterion and Hanan pin criterion, we used 10 legs for this VAR model, and then we checked stability of the model. We also checked the residuals. We also checked the correlogram, the normality, the LM autocorrelation LM test, and we also checked the heteroscedasticity using no cross terms. So this is how to estimate. In the next video, we will be using vector autoregression model for forecasting. So ladies and gentlemen, thank you very much for your attention. I hope this was informative and useful for you. Kindly subscribe the channel, and don't forget to click on the bell icon so that you can get notification about my other videos that I'll upload. I thank you for watching this channel. Kindly share this channel with your friends, with your colleagues, and with your students. Thank you.